Hello, in this lecture we'll answer two questions. In the first question, we'll find out the value of line segment X that is inside rectangle ABCD. The second question, we'll find out the value of this green area that is inside the semicircle. So we'll start with the first question. In the drawing, we have rectangle ABCD. Inside rectangle ABCD, we have a circle, and we know that the tangent from point A to this circle is equal to 33 units in its length. The tangent from point B to this circle is equal to 85 units in its length. The tangent from point C to this circle is unknown. That is the tangent that we are looking for. So we have to find out the value of the tangent from point C to this circle, that is actually equals to x. And finally, the tangent from point D to this circle is equal to 35 units in its length. And so as we mentioned, we have to find out the tangent from point C to this circle, that is equal to x. We have to find out the value of x. Okay, so first of all, we define the center of this circle as O. We will define the point of tendency of the tangent from point A to this circle as E. We define the point of tendency of the tangent from point B to this circle as F. And we will define the point of tendency of the tangent from point C to this circle as T. And finally, we will define the point of tendency of the tangent from point D to this circle as M. In the next step, we will join points O and D together by a straight line. Here, point O is the center of the circle, point M is the point of the circle itself, therefore OE is the radius of this circle that we will define as R. And we have here rule number 1. According to rule number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. So here we have tangent AB, that is tangent to this circle at point M. Point M is the point of tendency. And we have the radius OM that is drawn to the point of tendency. Therefore, according to this rule number 1, tangent AB will be perpendicular to the radius MO. That is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. We can implement rule number 1, this rule, in our drawing. In our drawing, we have the radius OE that is drawn to the point of tendency. Therefore, according to rule number 1, tangent AE will be perpendicular to the radius EO. That is to say, this angle will be equal to 90 degrees. In the next step, we will join points O and M together by a straight line. Point O is the center of the circle. Point M is the point of the circle itself. Therefore, OM is the radius of the circle that is equal to R. And again, we have the radius OM that is drawn to the point of tendency. Therefore, according to rule number 1, this angle will be equal to 90 degrees. Likewise, we join points O and F together by a straight line. Point O is the center of the circle. Point F is the point of the circle itself. Therefore, OF is the radius of the circle that is equal to R, and we have the radius OF that is drawn to the point of tendency. Therefore, according to rule number 1, this angle will be equal to 90 degrees. And finally, we join points O and T together by a straight line. Point O is the center of the circle, point T is the point of the circle itself, therefore OT is the radius of this circle that is equal to R, and we have the radius OT that is drawn to the point of tendency. Therefore, according to rule number 1, this angle is equal to 90 degrees. In the next step, we join points A and O together by a straight line. By joining points A and O, naturally created here, the right green triangle, triangle AOE. We will implement the Pythagoras theorem on the right green triangle, triangle AOE. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. By PT is abbreviation for Pythagoras theorem. So in the right green triangle AOE, AO square equals to OE square plus AE square. Repeat again, in the right green triangle AOE, according to the Pythagoras theorem, AO square equals to OE square plus AE square. So AO square equals to OE square. OE equals to R, therefore OE square is R square plus AE square. AE equals to 33 units according to what is given as the equation, therefore AE square is 33 square. So in conclusion, we found out that according to equation number 1, AO square equals to R square plus 33 square. In the next step, we'll join points P and O together by a straight line. By joining points P and O, we created here the right triangle BOF. So we implement the Pythagoras theorem on the right yellow triangle, triangle OBF. According to the Pythagoras theorem, in the right yellow triangle OBF, BO square equals to OF square plus FB square. Repeat again, according to the Pythagoras theorem, in the right yellow triangle BOF, BO square equals to OF square plus EB square. Okay, so BO square equals to OF square. OF equals to R, therefore OF square is R square plus naturally FB square FB equals to 85, therefore FB square is 85 square. So, in conclusion, we found out that according to equation number 2, BO square equals to R square plus 85 square. The next step, we'll join points C and O together by a straight line. And we'll implement the Pythagoras theorem in the right orange triangle OTC. According to the Pythagoras theorem, the right orange triangle OTC, CO square equals to OT square plus TC square. Repeat again. In the right orange triangle OTC, according to the Pythagoras theorem, CO square equals to OT square plus TC square. So CO square equals to OT square. OT equals to R, therefore OT square is R square plus TC square. TC equals to X, that is the line segment that we are looking for, therefore TC square is X square. So in conclusion, we found out that according to equation number 3, CO square equals to R square plus X square. And finally, we join points O and D together by a straight line. And we implement the Pythagoras theorem on the right pink triangle MOD. According to the Pythagoras theorem, in the right pink triangle MOD, DO square equals to MO square plus DM square. Repeat again, in the right pink triangle MOD, according to the Pythagoras theorem, DO square equals to MO square plus DM square. So DO square equals to MO square. MO equals to R, therefore MO square is R square plus DM square. DM equals to 35, therefore DM square is 35 square. In conclusion, we found out that according to equation number 4, DO square equals to R square plus 35 square. In the next step, I'll copy the 4 equations that we created from Pythagoras theorem by using the Pythagoras theorem in a new page. According to equation number 1, we found out that AO squared equals to R squared plus 33 squared. And according to equation number 2, we found out that BO squared equals to R squared plus 85 squared. And according to equation number 3, we found out that CO squared equals to R squared plus X squared. And finally, according to equation number 4, we found out that DO squared equals to R squared plus 35 squared. In the next step, I will copy triangle rectangle ABCD with its circle inside it in a new page, and analyze the rectangle ABCD with its circle. So this is actually rectangle ABCD that I copied from the original drawing with its circle inside it. We know that all the angles inside the rectangle are right angles, so those 4 angles are all right angles. This angle equals to 90 degrees. This angle it is equal to 90 degrees. This angle equals to 90 degrees. This angle equals to 90 degrees. You know that the center of this circle is point O. So from point O, draw perpendicular on BC. Okay, from point O, we draw perpendicular on BC. And we will extend the perpendicular from point O towards AD. So here, this angle equals to 90 degrees, and this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point O and BC as T. Because of the fact that side BC is parallel to side AD in rectangle ABCD, it means that the perpendicular from point O to BC must be also perpendicular to AD. Again, why? Because AD is parallel to BC. So here this angle will be equal to 90 degrees, and this angle also will be equal to 90 degrees. We define the touching point of the perpendicular from point O and AD as M. Likewise, from point O, we'll go perpendicular on AB. We will extend the perpendicular from point O towards DC. Again, here, this angle equals to 90 degrees, and this angle will be also equal to 90 degrees according to our construction. We define the touching point of the perpendicular from point O and AB as N. Again, because of the fact that side AB in rectangle ABCD is parallel to side DC, it means that the perpendicular from point O to AB must be also perpendicular to DC. Why? Because DC is parallel to AB. So here, this angle equals to 90 degrees, and this angle will be also equal to 90 degrees. We define the touching point of the perpendicular from point O to BC as point H. So inside quadrangle ANMO we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees plus the size of the fourth angle. In total, the sum of those 4 angles inside the quadrangle ANMO must be equal to 360 degrees according to the rule that the sum of the angles in any quadrangle is equal to 360 degrees. Therefore, the missing angle here must be equal to 90 degrees. Why? Because 90 degrees plus the sum of the other 3 angles, that is 270 degrees, it is equal to 360 degrees, that is the sum of the angles in any quadrangle. So in quadrangle ANMO we have 4 right angles, therefore this quadrangle ANMO is a rectangle. Likewise, in quadrangle MODH we have 1, 2, 3 right angles, therefore the fourth angle must be also equal to 90 degrees according to the same rule. Therefore quadrangle MODH before right angles is a rectangle. Likewise, in quadrangle NBTO we have 1, 2, 3 right angles, therefore the fourth angle must be also equal to 90 degrees, and therefore quadrangle NBTO is a rectangle. And finally, in quadrangle OTHC we have 1, 2, 3 right angles, therefore the fourth angle must be also equal to 90 degrees, and therefore quadrangle OTCH is a rectangle. So we found out that inside the big rectangle ABCD we have 4 small rectangles. Okay, and in the next step we will define side AM as H1. We will define side MD as H2. We will define side AN as B1, and we will define side NB as B2. We also know that the opposite sides of a rectangle are equal to each other. So in rectangle ANMO, side AN equals to side MO, but we know that side AN equals to B1, therefore side MO must be also equal to B1. Likewise, AM equals to NO. We know that AM equals to H1, therefore NO must be also equal to H1. Likewise, in rectangle MODH, side MD equals to side OH. But we know that side MD equals to H2, therefore OH must be also equal to H2. And MO equals to DH, but we know that MO equals to B1, therefore DH must be also equal to B1. Likewise, in rectangle NBOT, side NO equals to side BT, but we know that NO equals to H1, therefore BT must be also equal to H1. Also NB must be equal to OT, according to the rule that the opposite sides of rectangle are equal to each other, but we know that NB equals to B2, therefore OT must be also equal to B2. Here in rectangle OTHC, OH equals to TC, but we know that OH equals to H2, therefore TC must be also equal to H2. And finally, OT must be equal to HC, but we know that OT equals to B2, therefore HC must be also equal to B2. In the next step, we will join points A and O together by a straight line. And we will implement the Pythagoras theorem on the right green triangle, triangle A and O. On the green right triangle, triangle A and O, according to the Pythagoras theorem, we get that AO square equals to B1 square plus H1 square. I repeat again, in the right green triangle A and O, according to the Pythagoras theorem, AO square equals to B1 square plus H1 square. Likewise, we join points B and O together by a straight line, and we implement the Pythagoras theorem on the right yellow triangle, triangle NBO. On the right yellow triangle, triangle NBO. According to the Pythagoras theorem, we get that BO square equals to B2 square plus H1 square. Repeat again, in the right yellow triangle NBO, according to the Pythagoras theorem, BO square equals to B2 square plus H1 square. We join points C and O together by a straight line. And we'll implement the Pythagoras theorem on the right orange triangle, triangle OTC. On the right orange triangle, triangle OTC, according to the Pythagoras theorem, we get that CO square equals to B2 square plus H2 square. Repeat again, in the right orange triangle OTC, according to the Pythagoras theorem, CO square equals to B2 square plus H2 square, and finally we join points D and O together by a straight line. And we'll implement the Pythagoras theorem on the right pink triangle OMD. on the right pink triangle OMD, according to the Pythagoras theorem, we get that DO squared equals to B1 squared plus H2 squared. I repeat again, the right pink triangle OMD, according to the Pythagoras theorem, we get the DO squared equals to B1 squared plus H2 squared. So we have here two different expressions for AO squared, we have two different expressions for BO squared, we have two different expressions for CO squared, and we have two different expressions for DO squared. So in the next step we will create another four equations, and here the first equation that we will create states that AO squared according to equation number 1 must be equal to AO squared according to equation number 2. Again, AO squared according to equation number 1 must be equal to AO squared according to equation number 2. So here AO squared according to this equation number 1 equals to R squared plus 33 squared, and it must be equal to AO squared according to this equation number 2, that is equal to B1 squared plus H1 squared. Okay, that is to say, according to equation number 1, we found out that R squared plus 33 squared equals to B1 squared plus H1 squared. Likewise, we create equation number 2 that states that BO squared according to equation number 1 must be equal to BO squared according to equation number 2. BO squared according to equation number 2 equals to R squared plus 85 squared, and it must be equal to BO squared according to equation number 2, that is equal to B2 squared plus H1 squared. In conclusion, we found out that according to equation number 2, R squared plus 85 squared equals to B2 squared plus H1 squared. In the next step, we create equation number 3 that states that CO squared according to equation number 1 must be equal to CO squared according to equation number 2. CO squared according to equation number 1 is equal to R squared plus X squared, and it must be equal to CO squared according to this equation number 2, that is equal to B2 squared plus H2 squared. So in conclusion, according to equation number 3, we found out that R squared plus X squared equals to B2 squared plus H2 squared. And finally, we create equation number 4 that states that DO squared according to equation number 1 must be equal to DO squared according to equation number 2. DO squared according to equation number 1 equals to R squared plus 35 squared, and it must be equal to DO squared according to this equation number 2, that is equal to B1 squared plus H2 squared. So in conclusion, we found out that according to equation number 4, we created according to equation number 4, we found out that R squared plus 35 squared equals to B1 squared plus H2 squared. In the next step, we subtract equation number 2 from equation number 1. So it is 2 minus 1. And this will be equation number 5. So here in equation number 2 we have R squared plus 85 squared minus equation number 1. In equation number 1 we have R squared plus 33 squared. Now we we move to the other side of equation number 2, that is equal to here in equation number 2 we have b2 square plus h1 square minus equation number 1 we have here minus b1 square plus h1 square. Okay. Now we will open the brackets of this equation, equation number 5, and we get that according to equation number 5 we have here r square plus 85 square minus, we have minus in front of the bracket, so here it will be minus r square minus 33 square, that is equal to b2 square plus h1 square minus b1 square minus h1 square. So in this equation number 5 we have r square minus r square is 0, so r square will get cancelled. In the other side of equation number 5 we have h1 square minus h1 square is also 0, so h1 square will also get cancelled. So what is left from equation number 5 after we cancelled those two expressions? What is left is actually in this side of equation number 5 we left with 85 square minus 33 square, that is equal to b2 square. In the other side of equation number 5 we have b2 square minus b1 square. So actually we found out that according to equation number 5, 85 square minus 33 square equals to b2 square minus b1 square. Okay. In the next step, we'll subtract equation number 3 from equation number 4. So it is 4 minus 3. Okay, so here in equation number 4 we have, so this will be equation number 6. So in equation number 4 we have here r square plus 35 square minus equation number 3, we have here in equation number 3 r square plus x square. On the other side of equation number 4 we have b1 square plus h2 square minus equation number 3 we have here minus b2 square plus h2 square. In the next step we will open the brackets of this equation number 6, and we get that according to equation number 6 r square plus 35 square minus r square minus x square equals to b1 square plus h2 square minus b2 square minus h2 square. So in this side of equation number 6 we have r square minus r square, that is 0, so r square will get cancelled. In the other side of this equation, equation number 6, we have h2 square minus h2 square, that is 0, so h2 square will also get cancelled. So what is left from equation number 6 after we cancel those two expressions? In this side of equation number 3 we left only with 35 square minus x square, that is equal to b1 square minus b2 squared. In the next step, we will multiply this equation number 6, by minus 1. And we get that according to equation number 6, minus x squared times minus 1 is plus x squared. 35 squared times minus 1 is minus 35 squared. And it is equal to minus b2 squared times minus 1 is plus b2 squared. And b1 squared times minus 1 is minus b1 squared. So according to equation number 6, we found out that x squared minus 35 squared equals to b2 squared minus b1 squared. While according to equation number 5, we found out that 85 squared minus 33 squared equals to b2 squared minus b1 squared. In the next step, we create equation number 7 that states that b2 squared minus b1 squared according to this equation number 5 must be equal to b2 squared minus b1 squared according to this equation number 6. Okay, so here we have b2 squared minus b1 squared according to this equation number 5 equals to 85 squared minus 33 squared, and it must be equal to b2 squared minus b1 squared according to this equation number 6, that is equal to x squared minus 35 squared. So in conclusion, we found out that according to this equation number 7, 85 squared minus 33 squared equals to x squared minus 35 squared. In the next step, we will add 35 squared to this equation number 7, and we get that according to equation number 7, 85 squared plus 35 squared minus 33 squared equals to x squared. So here 85 squared is 7,225 plus 35 squared is 1,225 minus 33 squared is minus 1,089, that is equal to x squared. So here 7,225 plus 1,225 equals to 8,450 minus 1,089 equals to x squared. And 8,450 minus 1,089 equals to 7,361, that is equal to x squared. So according to equation number 7, we found out that x squared equals to 7,361. So here we take out of this equation number 7, and we get that according to equation number 7, x equals to plus minus square root of 7,361. So here we have two solutions that are possible for x. The negative square root of 7,361 and the positive square root of 7,361. But because of the fact that x is a length, is the length of the tangent from point C to the circle, x as a length must be a positive number, so we take into account only the positive solution. That is to say, x equals to 85.796 units. So the answer to the question is that the length of line segment X, the line segment from point C to the circle, the length of this line segment equals to 85.796 units. We finished with the first question. In the next step, I'll present to you the second question, and we'll solve the second question in two different methods. In the drawing, we have a semicircle. We know that AB, that is the diameter of the semicircle, equals to 6 units in its length. We know that angle BAC equals to 30 degrees. Our mission is to find out the value of the area of this ring shape. Okay. So first of all, we will define the center of this semicircle as O. We know that the diameter of this semicircle equals to 6 units, therefore the radius must be equal to half of it, that is to say the radius OA equals to 6 over 2, that is 3 units, and the radius OB also equals to 3 units. We'll join points O and C together by a straight line. Point O is the center of the semicircle, point C is the point of the semicircle itself. This is exactly the definition of a radius, that is to say, OC is the radius of this semicircle, that is equal to 3 units. So inside triangle AOC, AO equals to OC, they are both equal to 3 units, therefore they are equal to each other. And we have the rule that in front of equal sides in the triangle, there are equal angles. So those two angles that are located in front of equal sides must be equal to each other. But we know that this angle equals to 30 degrees, therefore this angle must be also equal to 30 degrees. So in triangle AOC, 30 degrees plus 30 degrees is 60 degrees. And we know that the sum of the angles in any triangle is equal to 180 degrees, so the missing angle here must be equal to 120 degrees. In order to complete the sum of the angles in triangle AOC to 180 degrees, this angle must be equal to 120 degrees. Okay. In the next step, I will present to you the area of a sector. The formula for the area of a sector. Okay, so if we have here a sector AOB, that could be any sector. This is sector OAB. OA equals to R, OB also equals to R. R is the radius of the circle that contains the sector. OA and OB also the legs of sector OAB. This angle theta is the angle that is between the legs of sector OAB. So OAB. Here, the rounded side above OAB is the sign for sector AOB. Again, this sign is sector AOB. And the area of sector AOB, this is how you find out the area of sector AOB. The area of this sector, sector OAB, is equal to pi r squared, that is the radius of the circle or semicircle that contains the sector, times theta over 360 degrees. Here, this ratio, theta over 360 degrees, gives us actually the relative percentage that this sector occupy out of the area of the entire circle, and when you will multiply this relative percentage by the area of the entire circle, that is pi r squared, you will get exactly the area of this sector. Again, the ratio theta over 360 degrees gives us the relative percentage that this sector occupy out of the area of the entire circle, and when you will multiply this relative percentage by the area of the entire circle, that is pi r squared, you will get exactly the area of this sector, sector OAB. So the area of sector OAB equals to pi r squared times theta over 360 degrees. In the next step, we'll use this formula in order to find out the area of this sector, sector AOC. So I copy sector AOC here in new page, and we'll use the new formula in order to find out the area of sector AOC. So actually, this is sector AOC that I copied from the original drawing. The two legs of the sector AO and OC, they are equal to 3 units. They are also the radii of the semicircle that contains the sector, and the angle between the legs of this sector is 120 degrees. So according to the new formula, the area of this sector, sector AOC, it will be equal to pi r squared. R is 3, therefore pi r squared is pi 3 squared times theta over 360 degrees. Theta equals to 120 degrees, so it is 120 degrees over 360 degrees. 3 squared is 9, so in total this expression equals to 9 pi. 120 degrees over 360 degrees equals to 1/3. So in total this expression will be equal to 9 pi over 3. 9 over 3 is 3, so in total this expression equals to 3 pi. So we actually found out that the area of this sector, sector AOC, is equal to 3 pi square units. Okay, So in the next step, I will present to you a new formula for the area of any triangle, and we'll use the new formula in order to find out the area of this triangle, triangle AOC. So if we have a triangle ABC that could be any triangle, this is triangle ABC. And we know that the length of side AB of triangle ABC is equal to A units, side AC equals to B units in its length, and the angle between side AB and side AC is theta. Then, according to the new formula, the area of this triangle ABC will be equal to A times B times sinus theta over 2. Okay, again, the area of this triangle ABC that could be any triangle is equal to A times B times sinus theta over 2. Now we use the new formula in order to find out the area of this triangle AOC. So we copy triangle AOC in this new page and we'll implement the new formula in order to find out the area of this triangle. So first, this is a triangle AOC that I copied from the original drawing. AO equals to 3 units, OC equals to 3 units, and the angle between side AO and side OC is 120 degrees. So according to the new formula, we get that the area of this triangle AOC is equal to AO times OC times sinus 120 degrees over 2. Repeat again, the area of this triangle AOC according to the new formula equals to AO times OC times sinus 120 degrees over 2. AO equals to 3, OC equals to 3, sinus 120 degrees equals to square root of 3 over 2, all divided by 2. So in the numerator we have 3 times 3 is 9, so in total we have in the numerator 9 times square root of 3 over 2 times 2 is 4, so in the denominator we have 4. So we actually found out that the area of this triangle AOC equals to 9 times 4 to 3 over 4 square units. We have already found out that the area of sector AOC is equal to 3 pi square units. But what is actually the area of the green shape? Here, from the drawing, it is very easy to see that the area of this green shape the area of sector AOC minus the area of triangle AOC. Repeat again, the area of the green shape equals to the area of sector AOC minus the area of triangle AOC. We already found out that the area of sector AOC equals to 3 pi square units minus the area of triangle AOC. We have already found out that the area of triangle AOC equals to 9 times square root of 3 over 4 square units. So in conclusion, we found out that the area of the green shape equals to either 3 pi minus 9 times square root of 3 over 4 square units, or in terms of numbers, it is equal to 5.53 square units. So we finished the first method. In the next step, I'll present to you how to find out the area of this green shape according to the second method. According to the second method, the area of the green shape will be equal to the area of the semicircle minus the area of triangle AOC minus the area of sector COB. I'll repeat again. According to the second method, the area of the green shape equals to the area of the semicircle minus the area of triangle AOC minus the area of sector COB. So what is the area of the semicircle? The area of the semicircle is equal to the area of the circle over 2. That is to say, it will be equal to pi r square over 2. The area of the semicircle equals to pi r square over 2. R equals to 3. It is the radius of the semicircle. So r square is 3 square. So in total, this expression equals to pi 3 square over 2. 3 square is 9. So in total, this expression will be equal to 9 pi over 2. So we found out that the area of the semicircle equals to 9 pi over 2 square units. We have already found out that the area of triangle AOC is equal to 9 times 4 to 3 over 4 square units. The only thing that is left to find in order to find the area of the green shape is to find out the area of sector COB, the area of this sector COB. In order to find out the area of sector COB, we have to find out the angle between the legs of sector COB. We know that AB is the diameter of the semicircle, therefore AB is the diameter, it is absolutely a straight line. So if we focus on the upper side of the straight line AB at point O, here the sum of the angles must be equal to 180 degrees, according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have here? In the upper side of AB at point O, we have this angle is equal to 120 degrees plus the missing angle. In total, they must be equal to 180 degrees. So the missing angle must be equal to 60 degrees. In order to complete the sum of the angles on the upper side of AB at point O to 180 degrees, this angle must be equal to 60 degrees. In the next step, I will copy sector COB in the new page, and we find out the area of this sector according to the new formula. So actually, this is sector COB that comes from the original drawing. Or C equals to 3 or B equals to 3, and the angle between the legs of the sectors is 60 degrees. So according to the new formula, the area of any sector is equal to pi r squared times theta over 360 degrees. Okay, so according to this formula, we get that the area of our sector, sector COB, equals to pi r squared. R is 3, so pi r squared is pi times 3 squared times theta. Theta is the angle between the legs of sector COB, that is 60 degrees, over 360 degrees. Here 3 squared is 9, so in total this expression equals to 9 pi. 60 degrees over 360 degrees, it is 9 over 6, so in total this expression equals to 9 pi over 6. Here we divide both the numerator and the denominator by 3. 9 over 3 is 3, so in total in the numerator we have 3 pi over 6 over 3 is 2. So in conclusion, we found out that the area of sector COB is equal to 3 pi over 2 square units. Now we can find out the area of the green shape. Okay. According to the second method, the area of the green shape equals to the area of the semicircle minus the area of triangle AOC minus the area of sector COB. Repeat again in the formula for the area of the green shape according to the second method is equal to the area of the semicircle minus the area of triangle AOC minus the area of sector COB. We have already found out that the area of the semicircle equals to 9 pi over 2 square units. We have already found out that the area of triangle AOC equals to 9 times square root of 3 over 4 square units, and finally we just right now found out that the area of sector COB equals to 3 pi over 2 square units. So here 9 pi over 2 minus 3 pi over 2 is equal to 6 pi over 2 minus 9 times square root of 3 over 4. 6 over 2 is 3, so in total this expression equals to 3 pi minus 9 times square root of 3 over 4. So in conclusion, we found out that the area of the green shape equals to either 3 pi minus 9 times square root of 3 over 4 square units, or in terms of numbers, it is equal to 5.53 square units. So we finish with the second question. In the next step, I will summarize the lecture and start with the first question, of course. So in the drawing, we have rectangle ABCD. Inside rectangle ABCD, we have a circle. Yeah, we know that the tangent from point A to this circle AE equals to 33 units inside. We know that the tangent from point D to this circle, that is to say, BF equals to 85 units inside. And we are looking for the tangent from point C to this circle, that is CT, that is equal to x according to what is given us in the question. So we have to find out the value of x, or the length of line segment CT is equal to x. And finally, the tangent from point D to this circle equals to 35 units in its length. Again, our mission is to find out the length of line segment CT is equal to x. So first of all, we defined the center of the circle as O. The radius OM is 1 to the point of tendency, therefore according to rule number 1, the circle equals to 90 degrees. The radius OH is 1 to the point of tendency, therefore here this angle equals to 90 degrees according to rule number 1. The radius OT is 1 to the point of tendency, therefore this angle equals to 90 degrees. And finally, the radius OF is 1 to the point of tendency, therefore this angle equals to 90 degrees according to rule number 1. We joined points A and O together by a straight line. In this way, we created the right triangle AOE. We implemented the Pythagoras theorem on the right triangle AOE. According to the Pythagoras theorem, or AO square equals to OE square plus AE square. AO square equals to OE square plus AE square. OE equals to R, AE equals to 33, so therefore AO square equals to OE, that is R, so OE square is R square, plus AE square. AE is 33, therefore OE square is 33 square. So in conclusion, we found out that according to equation number 1, AO square equals to R square plus 33 square. Then we joined points P and O together by a straight line, and then implemented the Pythagoras theorem on the right yellow triangle BOF. According to the Pythagoras theorem, BO square equals to OF square plus BF square. So again, BO square equals to OF square plus BF square. OF equals to R, BF equals to 85, therefore BO square equals to OF square, that is R square, plus BF square, that is 85 square. So in conclusion, according to equation number 2, we found out that BO square equals to R square plus 85 square. Then we joined points C and O together by a straight line. In this way, we created the right orange triangle COT. According to the Pythagoras theorem, and the right orange triangle CO square equals to OT square plus TC square. TO equals to R and TC equals to X. So in conclusion, we found out that DO square equals to R square plus 35 square. Then I copied the 4 equations that we created from the Pythagoras theorem in a new page, and then I copied the rectangle ABCD with circle inside it, and we analyzed the rectangle with its circle. This is rectangle ABCD with its circle inside it. We know that all the angles inside the rectangle are right angles, so those 4 angles are right angles. Then from the center of this circle, that is to say from point O, we drew perpendicular on BC, and we extended the perpendicular from point O towards AD. So this angle equals to 90 degrees, and this angle equals to 90 degrees according to our construction. But because of the fact that side AD is parallel to side BC in rectangle ABCD, it means that the perpendicular from point O to BC must be also perpendicular to AD. So this angle equals to 90 degrees and this angle equals to 90 degrees also. Then from point O, we go perpendicular on AB and we extended the perpendicular towards DC. So this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. Again, because of the fact that side AB is parallel to side DC, it means that the perpendicular from point O to AB must be also perpendicular to DC. So this angle also equals to 90 degrees and this angle also equals to 90 degrees. Inside quadrangle ANMO, we have 1, 2 right angles. The sum of right angles is 270 degrees, plus the size of the fourth angle. In total, they must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrangle is equal to 360 degrees. Therefore, the missing angle, the missing fourth angle, must be also equal to 90 degrees, because 270 degrees plus 90 degrees is 360 degrees. That is the sum of the angles in any quadrangle. So this angle must be equal to 90 degrees. So inside quadrangle ANMO, we have 4 right angles. Therefore, quadrangle ANMO is a rectangle. Likewise, in quadrangle MODH, we have 1, 2, 3 right angles. Therefore, the fourth angle must be also equal to 90 degrees. Therefore, quadrangle MODH is a rectangle. Likewise, in quadrangle NBOT, we have 1, 2, 3 right angles. Therefore, the fourth angle must be also equal to 90 degrees. Therefore, quadrangle NBOT is a rectangle. And finally, in quadrangle OTHC, we have 1, 2, 3 right angles. Therefore, the fourth angle must be also equal to 90 degrees. And therefore, quadrangle OTHC is a rectangle. So inside the big rectangle ABCD, we have 4 small rectangles. Then we define side AM as H1, side MD as H2, side AN is B1, and side NB is B2. We also know that the opposite sides of a rectangle are equal to each other. That is to say, AN equals to MO. But we know that AN equals to B1, therefore MO must be also equal to B1. Likewise, AM equals to NO, according to the rule that the opposite sides of a rectangle are equal to each other. But we know that AM equals to H1, therefore NO must be also equal to H1. In rectangle MO, the edge, MO must be equal to the edge. But we know that MO equals to B1, therefore the edge must be also equal to B1. Likewise, MD must be equal to OH, but we know that MD equals to H2, therefore OH must be also equal to H2. In rectangle ABOT, NO must be equal to BT, but we know that NO equals to H1, therefore BT must be also equal to H1. Likewise, NB must be equal to OT, but we know that NB equals to B2, therefore OT must be also equal to B2. In rectangle OTHC, OT equals to HC, but we know that OT equals to B2, therefore HC must be also equal to B2. And finally, OH equals to TC, but we know that OH equals to H2, therefore TC must be also equal to H2. Then we join points A and O together by a straight line. In this way, we created the green right triangle ANO. We implemented the Pythagoras theorem on the green right triangle ANO. According to the Pythagoras theorem, AO square equals to H1 square plus B1 square. And the green right triangle, ANO, and again, right triangle, ANO, AO square equals to B1 square plus H1 square. And then we join points O and B together by a straight line. In this way, we created the yellow right triangle NOB. According to the Pythagoras theorem, BO square equals to H1, BO square equals to B2 square plus H1 square. Again, BO square equals to B2 square plus H1 square. Then we join point C and O together by a straight line. In this way, we created the right orange triangle, triangle OTC. According to the Pythagoras theorem, CO square equals to B2 square plus H2 square. In the orange right triangle, CO square equals to B2 square plus H2 square. And finally, we created joint points D and O together by a straight line. In this way, we created the pink right triangle MOD. According to the Pythagoras theorem, DO square equals to B1 square plus H2 square. DO square equals to B1 square plus H2 square. So we have here two different equations for AO square, two different equations for BO square, two different equations for CO square, and two different equations for DO square. Therefore, we created equation number 1 that states that AO square according to equation number 1 must be equal to AO square according to equation number 2. Then we created equation number 2 that states that BO square according to this equation number 1 must be equal to BO square according to equation number 2. Then we created equation number 3 that states that CO square according to this equation number 1 must be equal to CO square according to equation number 2. And finally, we created equation number 4 that states that DO square according to this equation number 1 must be equal to DO square according to equation number 2. So, those are actually here. Those are the 4 equations that we created. Then we subtracted equation number 1 from equation number 2. That is to say 2 minus 1. So in equation number 2 we have here r square plus 85 square. Minus equation number 1 we have here r square plus 33 square. Then in the other side of equation number 2 we have b2 square plus h1 square. Minus equation number 1 we have here b1 square plus h1 square. Then we open the brackets of this equation number 5, and we found out that r square plus 85 square minus r square minus 33 square equals to b2 square plus h1 square minus b1 square minus h1 square. R square minus r square is 0, so r square will get cancelled. In the other side of equation number 5 we have h1 square minus h1 square is also 0, so h1 square will also cancel. So what is left from equation number 5 after we cancel those two expressions? What is left is actually in this side of equation number 5 we have 85 square minus 33 square that is equal to b2 square minus b1 square. Then we subtracted equation number 3 from equation number 4. In this way we created equation number 6. So in equation number, so it is 4 minus 3. Okay, 4 minus 3. So in equation number 4 we have r square plus 35 square. Minus equation number 3 we have here r square plus minus r square plus x square. In the other side of equation number 4 we have b1 square plus h2 square. Minus equation number 4 we have here minus b2 square plus h2 square. So we opened the brackets of this equation number 6, and we found out that r square plus 35 square minus r square minus x square equals to b1 square plus h2 square minus b2 square minus h2 square. R square minus r square is 0, so r square will get cancelled. h2 square minus h2 square is also 0, so h2 square will also get cancelled. So what is left from equation number 6 after we cancelled those two expressions? In this side of equation number 6 we have 35 square minus x square. On the other side of the equation number 6 we have b1 square minus b2 square. Then we multiplied this equation number 6 by minus 1 and found out that minus x square times minus 1 is plus x square, 35 square times minus 1 is minus 45 square, and it is equal to minus b2 square times minus 1 is plus b2 square, and b1 square times minus 1 is minus b1 square. So according to equation number 6, we found out that x square minus 35 square equals to b2 square minus b1 square. While according to equation number 5, we have only found out that 85 square minus 33 square equals to b2 square minus b1 square. Then we created equation number 7 that states that b2 square minus b1 square according to equation number 5 must be equal to b2 square minus b1 square according to this equation number 6. So according to equation number 7, we found out that 85 square minus 33 square, that is b2 square minus b1 square according to equation number 5, equals to x square minus 35 square, that is b2 square minus b1 square according to equation number 6. Then we added 35 square to this equation number 7, we found out that 85 square plus 35 square minus 33 square equals to x square. 85 square is 7,225. 35 square is 1225 minus 33 square is 1089, that is equal to x squared. So according to equation number 7, we found out that 7225 plus 1225 minus 1089 equals to x squared. 7225 plus 1225 is 8450 minus 1089 equals to x squared. So according to equation number 7, we found out that 8450 minus 1089 equals to x squared. 8450 minus 1089 equals to 7361. So in conclusion, we found out that according to equation number 7, x squared equals to 7361. We took the root out of this equation, equation number 7, and found out that x equals to plus minus the square root of 7361. So here we have two solutions that are possible for x. The positive square root of 7361 and the negative square root of 7361. But because of the fact that x is a length, it must be a positive number. Therefore, we'll take into account only the positive solution. That is to say, x equals to 85.796 units. Okay, so we finished with the first question. Then I presented to you the second question, and we solved the second question in two different methods. So, in the drawing, we have a semicircle. You know that the diameter AB equals to 6 units, angle BAC equals to 30 degrees, and our mission is to find out the area of the green shape. We define the center of the semicircle as O. The diameter equals to 6 units, therefore the radius must be equal to half of it. That is to say, the radius OA equals to 6 over 2, that is 3. The radius OB equals to 3. We join points O and C together by a straight line. Point O is the center of the semicircle, point C is the point of the semicircle itself, therefore OC is the radius of the semicircle, that is equal to 3 units. OC equals to 3 units, so in triangle AOC, AO equals to OC, they are both equal to 3 units, therefore they are equal to each other. And we have the rule that in front of equal sides in the triangle, they are equal angles. So those two angles that are located in front of equal sides must be equal to each other. But we know that this angle equals to 30 degrees, therefore this angle must be also equal to 30 degrees. So in triangle AOC, 30 degrees plus 30 degrees is 60 degrees. So here the missing angle must be equal to 180 degrees. In order to complete the sum of the angles in this triangle to 180 degrees, this angle must be equal to 120 degrees. Then I presented to you how to find out the area of any sector. So here we have sector AOB, that could be any sector. This is the sign of the area of sector AOB. The area of this sector equals to pi r squared times theta over 360 degrees. The ratio theta over 360 degrees gives us the relative percentage that this sector occupies out of the area of the entire circle. And when we will multiply this relative percentage by the area of the entire circle, we will get exactly the area of this sector. Okay, the relative percentage that this sector occupies out of the area of the entire circle times the area of the entire circle, that is pi r squared, will give us exactly the area of this sector, sector AOB. So the area of sector AOB equals to pi r squared times theta over 360 degrees. we use the new formula in order to find out the area of this sector, sector C or B. So I copy sector C or B in this new page, and we implemented the new formula in order to find out the area of this sector, sector A or B. AO equals to OC equals to 3 units. They are the legs of sector AOC, and they are also the radii of the circle that contains the sector. So it is the radius of the circle or the semicircle that contains the sector equals to 3 units. And the angle between the legs of sector AOC equals to 120 degrees. So theta equals to 120 degrees. So according to the new formula, the area of this sector, sector AOC, will be equal to pi r square. R is 3, so r square is 3 square, so pi r square is pi 3 square times theta is 120 degrees over 360 degrees. Pi 3 square is 9, so in total this expression equals to 9 pi. 120 degrees over 360 degrees is 1/3. So in total this expression equals to 9 pi over 3. 9 over 3 is 3, so in total this expression equals to 3 pi. So we found out that the area of this sector, sector AOC, equals to 3 pi square units. Then I presented to you how to find out the area of any triangle according to a new formula. According to the new formula, if we have here triangle ABC, that could be any triangle, and we know that the length of side AB is A units, the length of side AC is B units, and the angle between side AB and side AC is theta. Then according to the new formula, the area of this triangle, triangle ABC, equals to A times B times sinus theta over 2. The area of this triangle, triangle ABC, equals to A times B times sinus theta over 2. We use the new formula in order to find out the area of this triangle, triangle AOC. So I copy triangle AOC here. AO equals to 3, CO equals to 3, and the angle between side AO and side OC is 120 degrees. So according to the formula, we get that the area of this triangle, triangle AOC, equals to AO times OC times sinus 120 degrees over 2. AO is 3, OC is 3, sinus 120 degrees is equal to 3 over 2, all divided by 2. So in the numerator, we have 3 times 3, that is 9. In total, in the numerator, we have 9 times equal to 3. In the denominator, we have 2 times 2, that is 4. So in conclusion, we found out that the area of this triangle, triangle AOC, equals to 9 times square root of 3 over 4 square units, and we have already found out that the area of sector AOC equals to 3 pi square units. But what is actually the area of this green shape? From the moment, it's very easy to see that the area of this green shape equals to the area of sector AOC minus the area of triangle AOC. Again, the area of sector AOC minus the area of triangle AOC will give us exactly the area of this green shape. Repeat again, the area of the green shape equals to the area of sector AOC minus the area of triangle AOC. We have already found out that the area of sector AOC equals to 3 pi, so it is minus the area of triangle AOC. We have already found out that the area of triangle AOC equals to 9 times square root of 3 over 4 square units. So in conclusion, we found out that the area of the green shape equals to either 3 pi minus 9 times square root of 3 over 4 square units, or in terms of numbers, it is equal to 5.53 square units. We finished with the first method, then I presented to you how to find out the area of this green shape according to the second method. According to the second method, the area of this green shape equals to the area of the semicircle minus the area of triangle AOC minus the area of sector COB. I'll repeat again. The area of the green shape according to the second method equals to the area of the semicircle minus the area of triangle AOC minus the area of sector COB. What is the area of the semicircle? The area of the semicircle is the area of the circle over 2. The area of the circle is pi r square, and the area of the circle is pi r square over 2. R is 3, so pi r square is pi 3 square divided by 2. 3 square is 9, so in total this expression equals to 9 pi over 2. So we found out that the area of the semicircle equals to 9 pi over 2 square units. We have already found out that the area of triangle AOC equals to 9 times square root of 3 over 4 square units. The only thing that is left to find out in order to find out the area of this green shape is to find out the area of sector COB. In order to find out the area of sector COB, we have to find out the angle between the legs of sector COB. We know that AB is a diameter, must be a straight line. If you focus on the upper side of the straight line AB at point O, here the sum of the angles must be equal to 180 degrees according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the upper side of AB at point O? We have this angle is equal to 120 degrees plus the missing angle. In total they must be equal to 180 degrees. So 120 degrees. So the missing angle must be equal to 60 degrees. In order to complete the sum of the angles in the upper side of AB at point O to 180 degrees, its angle must be equal to 60 degrees. Then I copied sector COB in a new page and implemented the new formula in order to find out the area of this sector, sector COB. So this is sector COB that I copied from the original drawing. The angle between the legs of the sector is 60 degrees. OB equals to C equals to 3. Both legs of the sector. And we already found out that the area of any sector equals to pi r squared times theta over 360 degrees. R is 3, so pi r squared is pi 3 squared. 3 squared is 9, so in total this expression equals to 9 pi. 60 degrees over 360 degrees is 1 over 6. So in total this expression equals to 9 pi over 6. We divided both the numerator and the denominator by 3. 9 over 3 is 3, so in total in the numerator we have 3 pi, 6 over 3 is 2. In the denominator we have 2. So in conclusion we found out that the area of sector COB equals to 3 pi over 2 square units. Now it is very easy to find out the area of the green shape. I remind you that according to the second method, the area of the green shape equals to the area of the semicircle minus the area of triangle AUC minus the area of sector COB. Again, the area of the semicircle minus the area of triangle AOC minus the area of sector COB will give us exactly the area of this green shape. We have already found out that the area of the semicircle equals to 9 pi over 2 square units. We have already found out that the area of triangle AOC equals to 9 times square root of 3 over 4 square units. And finally, we just right now found out that the area of sector COB equals to 3 pi over 2 square units. 9 pi over 2 minus 3 pi over 2 is 6 pi over 2 minus 9 times square root of 3 over 4. 6 over 2 is 3, so in total this expression equals to 3 pi. So in conclusion, we found out that the area of the green shape equals to either 3 pi minus 9 times square root of 3 over 4 square units, or in terms of numbers, it is equal to 5.53 square units. Okay, thank you very much.